This question, as you can see, we've got two circles intersecting. Circle 1 has the equation x squared plus y squared equals 100. And circle 2 has the equation x minus 15 all squared plus y squared equals 40. They meet at the points A and B as shown here. And we've got to show that the angle AOB equals 0.635 radians, where O is the origin. Okay, so a good thing to start off with is let's just have a little look to see what that one represents. So it's actually this angle here. Okay? Right, so there's a number of different ways of doing this, but I think the most sensible way would be to actually consider the right-angled triangle that is in here. Okay? I'm just going to redraw that so we can see what that triangle looks like. Okay? Just labelling what we've got. We know this bit here, and we've actually got half of the angle that we want. I'm going to label that for the moment. I'm going to label that as angle theta. We know that angle AOB equals 2 theta. So just to make a note of that, because we're going to need that in a moment. We're going to label all the sides that we know. Okay. Do we know any of them? Well, yes, we do. We know this side here. This side here is, if you notice, the radius. So from O to A, that is the radius of circle 1. The moment our equation tells us that the radius is simply just the square root of 100. So it is 10. Right, so because we've got a right-angled triangle, if we can work out one of the other sides, we can then use trigonometry to work out what theta is. Right, so to work out this length here will actually be the value of the x coordinate there. Okay, now the x coordinate there will be where the two circles meet. So we're going to use a little bit of simultaneous equations with the two circle equations to work out what the x value is. So let's have a little look. We've got equation 1, which is x squared plus y squared equals 100. And we've got equation 2, which is there. And we're going to try and think, right, we want to find out the x coordinate, so we're going to eliminate y. So we're going to rearrange one of these to either be y equals or y squared equals. It's always preferable to do it with just the easier one to use. So I'm going to rearrange equation 1. And there we have it. We've got y squared equals 100 minus x squared. And that's equation 3. So I've just got that there. Now I'm going to sub my value for y squared into 2. So we've got the x minus 15 squared, and then that is plus 100 minus x squared equals 40. Do a little bit of expansion. Okay, because we're trying to solve for x, we'll do a little bit of tidying up. Well, the x squareds cancel out. So we end up with minus 30x on the left-hand side. And we end up with minus 285 on the right-hand side. Divide by minus 30. And you get 19 over 2. Okay, so that 19 over 2 represents that x value there. And because it is a movement along the x-axis, okay, so it's that movement along there, we can say that the length is quite simply 19 over 2. Okay. So, in order to work out what theta is, well, we know cos theta, and it's cos theta because we've got opposite, adjacent, and hypotenuse, so it's adjacent over a hypotenuse. So cos theta equals 19 over 2 divided by 10. And we'll put that into our calculator. So do arc cos and we get that answer there. And because it's show that question, it should be roughly half what we have. Okay. Now, going back to the original question, we're trying to show angle AOB is 0.635 radians. Well, as we've already stated at the start, we know angle AOB is simply just 2 theta. And there we have it, 0.635 radians.